Hello. This is FASTECH. I'd like to introduce how to select motor for the system which is integrated with the ball screw and the belt pulley together. The following box is an example of customer requirements. The weight is 65 kilograms. And a pulley diameter is 40 millimeters. Width is 22 millimeters. And travel distance and time is 80 millimeters, and 100 seconds. Acceleration and deceleration time is 50 seconds. The system is vertically attached and works as a Z-axis. The external force is 265 kilograms. To use FASTECH's motor selection guide, please access on FASTECH homepage, and put mouse pointer on the support tab. And then you can select motor selection guide. Or you can click the motor guide icon below the main window. If you go to the motor selection guide screen, you can select and use 4 types of systems as follows. The current system is a ball screw and belt pulley combined system, so if you select a ball screw plus belt pulley, you will see a screen like this. If you scroll down, you will see a screen where you can enter the data. There are several boxes, and you only need to enter the data in the yellow boxes. Total weight of table and work is 65 kilograms. So, enter 65 in this box. The diameter, hole length, and pitch of the ball screw can be entered by referring to the catalog of the ball screw used by the customer. Enter 4 because the diameter of the pulley is 40 millimeters, and the unit is in centimeter. And enter 2.2, because the width of the pulley is 22 millimeters. Next part is the external force. External force is a force that is continuously applied to the load, excluding the weight of the table and workpiece. In this example system, enter 265 because the external force is 265 kilograms. The installation angle is 90 for Z-axis. Enter 8 cm for travel distance. 100 seconds for positioning time and 50 seconds for acceleration-deceleration time. Since the gearbox is not applied, enter 1 for the gear ratio and 1 for the efficiency. This is an example without a gearbox, but if you use a gearbox, you can enter the gear ratio of the gearbox. In the case of gear efficiency, if you use a planetary gearbox, the efficiency is generally 90%, so please enter 0.9. If it is a 2-stage planetary gearbox, the value would be 0.9 times 0.9, which is 0.81. If you use a worm gearbox, the general efficiency is 50%, so please enter 0.5. The safety ratio is an empirically selected value by the engineer considering uncertainties. As in the case, when there are few uncertain factors and all items can be clearly stated without error, the recommended safety ratio is 1.5 to 2, and in this example, 2 is applied. It is recommended to use a higher safety ratio if the input value contains an uncertain factor such as an external force that is difficult to calculate accurately. When you finish entering and click Calculate, the calculated result is displayed as shown on the screen. The values we need to check are the rotation speed and operating torque of the motor at the bottom of the motor selection section. As the example was calculated, it turns out that we need to find a motor that can produce torque larger than 5.54 Nm at 24 rpm. Please click the button here to see the torque graph of the motor. Torque graphs from 20 to 86 mm size motor will be shown. 86L and 86XL motors produce torque larger than 5.58 Nm at 24 rpm. In this case, we will choose 86L sized motor, which has smaller size. Please remember that the moment of inertia value at this time is 3600 gram/cm and the torque value is about 6 Nm at 24 rpm. We need to check the validity of the motor by entering the inertia value in this box and calculating the required torque with the motor inertia. If you enter 3600 as the moment of inertia of 86L motor into the yellow box and click Calculate, the required torque value is calculated as 5.54 Nm considering the moment of inertia. Since 86L motor can produce the torque of 6 Nm at 24 rpm, 5.54 is an acceptable range. Finally, let's verify the validity of motor selection by calculating the moment of inertia ratio K. The moment of inertia K is the value obtained by dividing the inertia of the load by the inertia of the rotor. And if it exceeds the recommended inertia ratio, the motor may step out, stop or vibrate. Typical stepping motors allow inertia ratios from 1 to 5 to 1 to 10, whereas closed-loop stepping motors can allow inertia ratios of up to 1 to 30. It is not recommended to use the motor if this value exceeds 30 because it might cause problems. If the load inertia is too large and the inertia ratio exceeds 30, use a larger motor or a gearbox to reduce the inertia ratio. In this case, the inertia ratio is 0.35, so we assume that 86L size motor is suitable for the example system. On the FASTECH website www.fastech-motions.com, you can download product-related materials such as catalogs, manuals, drawings, and watch demonstration videos, and webinars. Also, if you search FASTECH on YouTube, you can see more than 100 demonstration and webinar videos. Thank you for listening.